Hallo? Hello. Due to lack of attention to details, we have had some time to talk and mingle before the show started. But now I think it's time to go on. Dear colleagues and guests, welcome to our mini-seminar on open data skills. I am Leah Rasmussen, proud hostess of this afternoon and a very proud head of the science library, which is 4 years old today. A main role of the academic library is to provide support to the researcher by giving access to the right resources and tools during different phases of the scientific process. As open access to science output, open collaborative science, and open data constitute a major shift in the whole research cycle, we, as an academic library, must adjust our services and our competence accordingly. Currently, the library works with the University ICT department, which is here today, and the Education and Research Administration Office to build future support services for research data sharing and storing. The discussions on what skills are required and in what way we can integrate teaching of these and other open data skills into existing courses and activities are really complicated and is conducted on many levels. So it will take so much time to find solutions for the whole University of Oslo, as many of you will know. However, the Science Library is always keen on putting thoughts into action at the first junction possible. We find the subject of open data skill extremely appropriate to our overall mission and to our aim to promote a culture of sharing knowledge. Therefore, we shamelessly grabbed this opportunity to turn our 4th anniversary into a happy open data skills birthday, a week full of workshops and meetings between experts, which we will hear from, and novices from our institution and outside. We are thrilled to host over 100 people teaching and being taught hands-on software and data skills in 5 different workshops the coming days. So this mini-seminar kicks it all off, and our first keynote, you're already there, yes. He is part of a working group that's launching a new summer school on behalf of the Committee on Data for Science and Technology, the CODATA, which is a committee under the International Council for Science. The invitation to sign up for the summer school states that all contemporary research, particularly when addressing the most significant transdisciplinary research challenges, cannot be effectively done without a range of skills relating to data. And we couldn't agree more. So Hugh Shanahan is a senior lecturer in computer science at the Royal Holloway, University of London. And the title for his talk is Introduction to Open Research Data and Training. Please give him a warm hand. A warm welcome, a hand.
Okay. All right, thank you. So can everybody hear me? Okay. Before we get started, I am aware that we have a spectrum of people, a scary array of software carpentry people who will look at this and think, yes, and hopefully there'll be some other people for whom this will be some new material. Just a few points also to make. I do have a tendency for my voice to just go down, the volume to go down to nothing, or to talk too quickly. So please don't be, you're not being rude if you at the back or anywhere shout at me and say, speak up, talk more slowly, whatever, okay? So I'm going to cheat a little bit. I'm going to talk about, in terms of this really, really nice session, this lovely relaxed arrangement we have here, and talking about looking at the training that's going on for open research data, I'm going to talk about this one implementation that myself and my colleagues are working on. Here's just my sort of megalomaniac quality. If you want to email me after this, or if you want to follow me on Twitter or whatever, just give me a shout. Okay. So let me give a little bit of motivation. And I want to explain that I'm actually a researcher myself, and I come at it as a researcher rather than, say, as a data manager and so on. So bear with me while these motivations all come from the research side of things. Okay? So, as was very nicely put before I even came up here, there's really a clear need for data science skills amongst researchers generically. And there is one particular angle that the schools that we're proposing are very much focused on, is that this is particularly true for researchers from low and middle income countries. All right? There's a huge amount of open data that's out there. Researchers from LMICs really have a fantastic opportunity to go and do cutting-edge science with all of that data that's out there. Okay? So this is a moment for them to actually get a jump ahead and really, really push forward. And this is very much one of the things we really, really believe very, very profoundly on, and sort of has predicated much of their choices for the initial locations for these schools. Now, I work in a computer science department, and one of the things we've done is that we don't talk about, for this school, we don't talk about data science, we talk about research data science, all right? Because quite honestly, with respect to data science, especially when you talk to computer scientists, they tend to think of it as this set of skills, quite specific, quite techie skills, machine learning, big data analytics, MapReduce, all of those sort of things. All right, how do I make sense of Twitter streams and all of that business? And one of the things we want to make clear here, and I think it's very obvious from the software carpentry movement, data carpentry movement, that these skills, although this perhaps forms some subset somewhere down the road, is only a subset. There's a lot of other things that are needed there. And actually, that chimes a lot with those of you who are working, for example, in the library sector. Okay. So, with respect to the schools that we're organizing, the curriculum is very much focused for researchers. Okay? That's the schools that we're setting up here. Okay? And as I said, what we try to do is just give some introduction on a set of generic skills. So with respect to our schools, sometimes people say to us, okay, well, is this for bioinformaticians or is this for social science people? Say, no, in our current iteration, we're going to say anybody who's coming in there, who's starting a Ph.D., who works with data, we want you to come along to these schools. All right? And the thing I'll be doing, and it's great that I know that we're going to be followed up by all the people from Software Carpentry and Data Carpentry. I don't have to actually explain this in great detail. I'll leave that to them, which is this very, very just practical set of skills, learning by doing, rather than one lecture after another. Okay? And, to know these are a set of skills that we're talking about here that go way back, when people started doing, for example, the Strat O'Reilly survey. Even you could say it went back much further than that. So what do we mean by that? And again, I'll go into more details about that actual curriculum, but let me give that overview, which is, number one, annotate and publish your data, okay? Getting a researcher to understand that it's important to manage their data, annotate it appropriately, and then actually get it out there. Extracting and manipulating their data, all right? Understanding that all the time, your data is not actually on a plate for you. You have to spend most of your time working, getting the bits of data that you actually want from a particular data set. Analyzing and making sense of the data, which is really the kind of key skill for a researcher. And that's two sides of that. One is the visualization side, and the other side is understanding the significance of your data. And the last point is something that has sort of, we realized was missing in what we were doing. And we've tweaked our curriculum a little bit, which is all of this is very, very, do this, this is good for you, do this, and so on. And there's a leitmotif going on here, which is about openness. Okay? And we realized that actually what we need to do is to get people stop and thinking about that explicitly, rather than what we were initially doing, which is more or less kind of whispering this in people's ears and hoping that they would pick it up. Okay. So, to explain, we're going to do the schools that we're organizing. They will run over 2 weeks. All right. We will give them a break on the Saturday and the Sunday. So some may say that's too much. Others will say that's actually not enough. Okay? But what we're going to do is we've got things that are running during the daytime, and if people want to do extra things, say work with it, say, oh, I've got my own data set and I want to try out my skills, do seminars, we'll organize that for things in the evening. All right? So here's what happens. It starts on working from Monday through to the Friday. So on the first day, what we'll do is we'll introduce open research data, okay? That whole data management side of things. And we'll also introduce a specific section on open science, which is not a huge chunk of time, but it's an hour, but just enough to get people reflecting and thinking. Then, for the rest of that week, we'll have data carpentry followed by software carpentry. The following week, sort of halfway through, we get started on a course on visualization of data. And again, remind people, why do you do open science? Then, for most of the rest of that week, we'll talk about, again, visualization and analysis. In other words, statistical inference of data, doing machine learning, those aspects there. Then finally, we wrap things up with a course on what we've titled computational infrastructures, which I'll explain to you in a little bit. Okay. Now, on top of that, assuming that our introductory schools work well, we have a longer-term vision in place. Now, we've only just put through the proposals for this to our hosts, and they still have to come back to us. But the idea is that we have our introductory school, which in some respect is setting up a common sort of generic set of skills that people will have. And that on top of that then, we build more advanced schools, which people can then pick and choose as they want. And if the introductory course is decidedly generic, we may try and pick specific data sets as we work along, but it tries to be as generic as possible. These advanced courses tend to be more specific, or will be more domain-oriented. All right. So, for example, advanced one might be, say, a bioinformatics course, and it says, okay, people have come along, they've got these materials, now they can go. We've taught them how to walk, now we'll teach them how to run in their area. So let me now spend a little bit more time talking about those individual courses, those individual modules that we had in there. Okay. So the first one was, as I said, this open science, okay, which is, again, it's not actually teaching anything per se, it's there to get people to reflect on things. So that's just going to be sort of short seminars saying, there's an idea, open science, it's really useful for you. Why is it that it's important? And then getting people to do more open table sessions where people are saying, well, how do you think this could have an impact for you? As I said, one of the things we really, really want these schools are very much oriented towards researchers from low and middle income countries. Many researchers from this area can see open science as very much something that, oh, okay, yeah, that's another thing that, Harvard University thinks is a really nice idea, but, come on, I got my career to worry about. And actually, the whole point about this is saying, no, it's something it's effective. It's really, really useful for you. It's not just being nice, it's something that can turbocharge your science. The section on open research data in a day and a half will try and just introduce the ideas of data sharing and open research. So what we'll do is over that period we'll introduce excuse me, the idea of publishing your data. Why is it that it's important to curate the data and providing the right sort of metadata standards? Why is it that all of those are using, for example, agreed metadata standards is something that's really, really useful, okay? Again, all of this is oriented towards researchers who are, for the most part, going to go in there and say, well, what has this got to do with my next paper? And so, again, this is motivating and saying, no, it really, really makes you more efficient, okay? And with publishing your data sets, again, that's a serious win for you. With respect to software carpentry, our colleagues there will provide us with 3 of their fairly standard courses. So obviously they'll do the Unix shell and Git courses that are there. And what we've decided to do, not, I have to stress, for in any way, a religious choice or anything like that. I'm a big fan of Python myself, okay? We're lumping for OR, and that's going to be the language of choice effectively for the whole school. If you ask me in a year's time, should we use Python rather than OR? Again, I think it's a point which is arguable. As you said, we're open. We just think for the first time we'll do this with OR, particularly for dealing with the visualization courses. All right. From our colleagues in data carpentry, what they'll be doing is introducing the idea of using databases, giving that motivation. Why is it that it's worth using databases? And introducing SQL databases, okay? How do we get to queries, aggregations, joins, those sort of concepts? Personally, I have, if I regard these as sort of the high learning aims, I have a personal low learning aim, which is if I can persuade one student to stop handing me Excel spreadsheets, which are tens of megabytes long, I will be jumping up and down and say, yes, my time has been well spent, all right? How are we doing for time? Okay, 2 minutes. All right. Our visualization course, again, will do things in OR, and we'll have a workshop there. So instead of just sort of saying, here's the right way of showing data, here's the right way of showing data, we'll say to people, okay, go. Here's a bunch of data sets. Now you go and visualize it. We've shown you the tools. Analysis will be a combination of statistics and machine learning. That's going to be the trickiest one, I think, of the lot. There's a lot of material that we need to try and fit in there in that 2-day period. But this is the start of a process and seeing what works. And then finally, this computational infrastructures course is basically about introducing people to cloud computing. So in particular, how do you get a virtual machine started? How do you use either a batch scheduler or how do you use a container? Okay. I think I can pretty much jump over this particular slide because we've got so many representatives from Software and Data Carpentry. This is a phenomenal pedagogical model that Software and Data Carpentry have put together. It's just fantastic. And I want to stress again that all we're doing is we're saying what Software and Data Carpentry are doing is fantastic, and we'd like to add on to that. And hopefully we're adding on and adding something useful to what they're doing already. Okay. In terms of the long-term vision, I think with this activity and all the activities, for example, that's going on here and elsewhere, I think the long-term success is where everybody in 5 to 10 years just shrug their shoulders, and it's just become something that's just part of every university, degree, research-led degree, that you have this course stuck in there and people go and make use of it. The medium-term success, to get to that point here, is about scaling up schools. So one of the things we want to work on is that we will have lots of assistant instructors in there who we hope will become the next generation of instructors. Okay, so our first school is going to run this August from the 1st to the 12th. It's going to be happening in Trieste in Italy. So Trieste, the ICTP, the International Center for Theoretical Physics, is a United Nations body, and they're very much mandated to assist developing world science. So they run workshops, summer schools all the time, and they've got the framework for doing these kind of things. And we've got funding, initial funding from these organizations here, including CODATA. We're aiming for up to 90 attendees, maybe somewhere between 60 and 80 attendees would be great. Okay? If you're interested in this, here's our link. Just in case you don't know your geography, there's Trieste. And let me also just, again, I'm going to be shameless and show you just some, here's the building where it'll all be happening, and this is the view from the building, all right? But of course, nobody will be paying attention to that because they'll all be working in the basement. All right. The last thing I'd just like to add, I know I'm running over, is just to note that these guys here are my partners in crime, Andrew Harrison, who's based at the University of Essex, and Simon Hodson, who's the Executive Director of CODATA. All right, thank you. That's everything. Thanks.
Thank you very much, Hugh, for coming all the way to talk to us. And you will have some time to talk to the Software and Data Carpentry people later on. And this is just a little bit of chocolate to take home or eat in your hotel room. Thank you. Yeah. Many of us here have attended a software or data carpentry workshop, and many might just have a vague idea of what it is. Tracy Teal works at the Michigan State University and the Kellogg Biological Station, but more importantly, she's the Director of Data Carpentry and will enlighten us on the Data Carpentry and Software Carpentry Initiative. So please welcome Tracy Teal.
All right. Oh, it is on. Perfect. This is really exciting. There are balloons on the stage, and I have this headset. I feel like it's like, I don't know. My talk should be way more exciting than it's actually going to be. So thank you so much for inviting me to be here today. I'm really excited to get to talk about this, but I'm also just really excited for the event that you've put together here, one that is associated with the library. We're really seeing libraries as being really a key piece in thinking about data and open science. And especially this particular event that you've put together that's about learning these skills, but also about community and developing a community of practice and engagement around these. So I'm just really happy to be a part of this. So what I'm going to do is I'm going to talk a little bit about data carpentry and software carpentry, what we do, what our goals are, and luckily I can skip my first 4 slides since Hugh set me up to describe, in a good way, about the needs for these. And we are working with Hugh, as you saw, for these CODATA programs, so we're really excited for that opportunity. Something that's not surprising to anybody is that our increasing capacity to collect data is changing research. So here's, the big 3: variety, volume, and velocity. So we're just gathering data in ways that we haven't been able to before. I mean, it's really changing the potential for what we can do in our research. And this isn't just in science, right? This is also in social sciences, in the humanities, a lot of text generation, large databases of survey data. So there are just a lot of opportunities across all areas of research. However, in most cases, rather than being excited and inspired by the data that's available, people are frustrated. They're yelling at their computers, they're yelling at their colleagues, or just being sad. So what we want to do is really be able to enable people to use this research and turn this data, instead of being a challenge, into being an opportunity. And working with these large data sets, for a while it was sort of the domain of specialists. You had sort of your statistical consultants or your CS folks who you could turn to work with specific sort of analyses applications. But now, because of the pervasiveness of this data, this is something that really everybody needs to be able to do to be able to make research progress. And it doesn't mean that you need to be able to do statistical modeling or advanced parallel computing, but just being able to get started with that data, understanding what it looks like, figuring out what the next steps will be, communicating with people who maybe do have specific skill sets. So this is something that really is a fundamental literacy component to research now. So the same sentiments that Hugh was saying. And so Hugh was saying this is really important, especially in emerging economies. But what's interesting is that really a lot of people in these areas are really at the same place as most of us. So we actually ran a workshop at Kenya this summer, and they said, oh, we feel like we're so far behind. And the instructor said, no, you're not. Everybody's behind. You guys are all on the same page. So this is a real opportunity to teach broadly these skills and enable researchers from really diverse backgrounds. So the question is, how do we scale this data and software literacy along with the data production? And training is really this missing piece. It's a missing piece between data collection and our ability to do data-driven discovery. And the challenge is that at a university settings, either undergrad, graduate curriculum, it's still not in the curriculum yet. Some of it is the challenges of changing university curriculum, but we still don't necessarily have the instructors at a university who can teach these skills. It is a newer skill set. So there are challenges in how to best deliver these training opportunities. And it's not just us saying, people need to learn these things, you guys should go out and do this. It's researchers themselves that are asking for this training. So for a survey of the Bioinformatics Resource Australia, the most useful thing that Brainbow could do, you can see, is 50% is offer training. That's more than funding, that's more than compute. I mean, when did you ever see things that are more important than funding? Right? So it's researchers themselves that are really looking for opportunities to learn these skills. So as I said, where does this training come from? So what data and software carpentry are looking to do is to develop and run workshops to fill that training gap. And our goal is to provide high-quality training covering the fundamentals and best practices in the full life cycle of data-driven research and software development. So that means what we're not trying to do is teach everything that you can do. What we're trying to really do is build that foundation, teach the fundamentals that are going to enable people to get started, to have good practices, and be able to empower them to go on to do more, to continue learning, and to get started with their own data and software projects. So Software Carpentry was founded in 1998 by Greg Wilson and rebooted in 2010. And they teach basic lab skills for scientific computing, so the researchers can do more in less time with less pain. Data carpentry was started more recently in response to this vast amount of data that's being produced in 2014. And we teach the basic concept, skills, and tools for working more effectively with data. These workshops are specifically designed right now for people with little to no prior computational experience. And the really interesting thing about software and data carpentry, and what I really love about getting to be the director of data carpentry, is it's a grassroots training effort. These lessons, these workshops, they're developed by practitioners for practitioners. So they're people who are working in this space, so they understand the skills that are needed. They understand where researchers are coming from. So we identify these skills and best practices needed in software development, data management, analysis in given domains of research. These lessons are all collaboratively and iteratively developed. So they're all CCBY, so all of our materials are online. They're free to use, for you to teach, for you to go through by yourself. You can adapt and change them. And these lessons have over 100 contributors to them across software and data carpentry. So as people teach them, they find what works, what doesn't work. So they're consistently getting better by being used in hundreds of workshops. But ultimately what these lessons are used for is to organize and develop 2-day intensive hands-on workshops in the fundamental data analysis skills and software development schools using volunteer helpers and instructors. So I'll talk a little bit more about each aspect there. Okay, so workshops. So what is a workshop like? So our workshops, they're 2 days and they're intensive. They're 9 to 5. And so we try and fill up everybody's brains. But the key component to them is that they're not a lecture style. They're hands-on. So what we do is before the workshop, we ask everyone to install the software that we're going to be using in the workshop. So that's R or Python or SQL, command line, so that their computer is set up to be able to do these things. And the workshops follow a I, we, you model, where the instructor will go through a concept. Then you'll practice and exercise together as a class, and then you give an exercise to the students for them to work through on their own and come back and answer that question. So not only are the people learning about these skills, but they have the opportunity to practice it immediately and get immediate feedback on how it's going. We have the instructor at the front of the room, but a key part of the workshop, and I know there's lots of people here who are helpers. And they stand in the room, and if someone runs into a problem, they come over and they can help one-on-one. So again, people are getting that immediate feedback, finding out where their misconceptions are and correcting them in the context of the workshop. So another really important part of these is that it's a really friendly learning environment. We have a code of conduct for all of our workshops that we emphasize at the start. And the key is that we want to make it a space where people are excited about these things, they're not intimidated, they feel like this is a place that they should be. Especially in computational settings, a lot of people have had experiences that have been less than positive necessarily. It just wasn't the right match, the workshop that they attended. And so we want to make sure that people leave these workshops feeling confident and excited about these topics. So another key element to software and data carpentry are the instructors, and this is the heart of the organization. So all of our workshops are taught by volunteer instructors. For both software and data carpentry, total we have a staff of 4 people, and we run workshops, hundreds of workshops a year around the world. And so what we do is that we have an instructor training program that trains researchers to be instructors. And then these instructors go out and teach these workshops. And so this instructor training program, we have over 400 instructors right now. We have a huge demand for more people to be more instructors. There's about 100 and something people on a wait list. And people are excited to be a part of helping others learn skills that they probably learned themselves and spent a lot of time cursing. So they want to help other people. But also, it's just a really great community to be a part of. I love this community of instructors, and they just are really a great group who want to share their knowledge. Very committed, in most cases, to reproducible science, to open science. And so it's a great group of people, and we help each other with our best practices, as well as delivering these workshops. Now, to speak to the curriculum, I talked a little bit about this already, but the point is that all of our lessons are here. They're on GitHub. So each lesson starts with these learning objectives, and then we go through and introduce these topics and include exercises. So we teach from these materials for our workshops, but they're there for learners to refer back to, for instructors to use in other contexts. I'll see on Twitter, a lot of times people saying, we're using the data carpentry materials to teach X, and I've never heard of these people, and I'm so excited to see that, right? It's fantastic to know that something that you developed is being used and being helpful for people. So that's really, this curriculum is a really core part of our organizations as well. A little just quick overview on data carpentry and software carpentry in particular, and I know I have too many words on this slide. So data carpentry, we're not saying, oh, we want to teach you to be data scientists. What we want to teach you is how to work with your data, how to work with your data in a research context. Our initial focus is for novices, so there are no prerequisites. We're not asking people to have experience before they come to the workshops. And our workshops are domain-specific by design. So we have lessons in ecology, in genomics, developed with iPlant, and in geospatial data. We are piloting those for the first time here this week with Leah A, who will be speaking in a bit. And the reason for the domain specificity is that we wanted to give people the skills to immediately work with their own data. So if in a workshop they're seeing the types of data that they work with, then they can build the skills on top of that framework of what they already know about. Then when they go back to their lab, the kind of data that they're working with is the kind they just went through in the workshop. So it makes that learning curve a little bit smoother. I don't have this listed here. We have some development in social sciences. We don't have a full workshop there yet, but we have a lesson on text mining. So this is the curriculum. I won't go through that too much. The curriculum changes a bit depending on the domain because we really want to teach the skills that are relevant to that domain. Software carpentry is focused on better scientific programming practices. So once you've been programming for a little while, what Greg found and that we saw as well is that when you start to program and you're sort of self-taught, you don't necessarily use best programming practices. So what software carpentry aims to do is teach good programming practices to be able to be more effective and reproducible with your software. There are novice and more advanced levels for software carpentry, and it's domain agnostic because whereas this sort of data focus means that different people are working with different data types, in software carpentry, software is software, and so it doesn't have to be as specific to the domain to think about best programming practices. So this curriculum is more specific and includes command line, software development, best practices in R, Python, or MATLAB, and GitHub for version control. We've taught workshops since 2014. The majority of these are software carpentry, as data carpentry is newer, but over 300 two-day workshops to over 9,000 learners, taught by over 200 volunteers in over 20 countries. So this is really a worldwide initiative. Some broad take-homes, people are learning things. One of the goals, obviously, is we have sort of two major goals in our workshops. One is this idea of this confidence and empowerment for people to go out and feel like they can use these skills in their own work. But the other is also for them to learn the things we're teaching, obviously. So we do see changes in the types of, in the responses in terms of what their experience is. And what's really great, they feel this workshop is worthwhile. So most of our respondents will say that they agree or disagree, or they agree or strongly agree that this is something that was worth their time. And so that's really important. They feel like it's something that they can apply directly to their work, and that it's something that is going to advance their skills. So opportunities to be involved with software and data carpentry, and Lex and Karin are going to speak next about how University of Oslo has been involved. You can request workshops, so that's one way if you want to host a workshop at your institution or department. You can be a helper at these workshops. We have a lot of helpers here today. Become a partner or an affiliate and train local instructors, or contribute to lesson development. So there are a lot of pathways to being involved. I think that's all I have. And so, yeah, so both organizations, I don't have this slide up here, are not only have a lot of volunteers that make everything possible, but also have steering committees that guide both of them. So both software and carpentry and data carpentry have steering committees. So Karin is on the software carpentry steering committee. So they put in a lot of work to keep these organizations going too. So we're really grateful to all volunteers who put in their time to make these what's possible here. So I'll just finish there. Thanks.
Thank you.
Is there time for questions or no? Is there time for questions?
There will be time for questions afterwards.
Okay, great.
So here's your little box of chocolate. Thank you very much. And thank you also for doing instruction 2 days. And I think the people that sign up for your software carpentry and data carpentry workshops are very lucky. Next ones are Lex and Karin, and without them, there wouldn't be a workshop. I still don't think we would have had one single workshop at the University of Oslo. Karin Lagesen and Lex Nederbragt, they are both bioinformaticians. Karin works at the Veterinary Institute and the Department of Informatics, and Lex is at the Department of Biosciences. So what is worth knowing about software and data carpentry at the University of Oslo? They know.
Thank you very much for this welcome and fantastic introduction. So my name is Lex Nederbragt. I'm working at the biology building, and I have a 20% position at informatics. Part of it is research, part of it is training, part of it is teaching, and I'll talk a little bit more about how we started getting involved with software carpentry.
Forgot to turn the thing on. My name is Karin Lagesen, and I'm most of the time at the Veterinary Institute. I used to be at the biology department. We used to share an office, which is basically where things got started. And I'm also at the informatics building in a 20% position with teaching and training and so on. And I'm also, as Leah mentioned, a steering committee member for software carpentry.
So how did this all start? I am, and Karin partly as well, a self-taught bioinformatician. I don't have any formal training in programming or using these tools for large-scale data analysis. So I felt the pain that most of the workshop participants feel. And I found software carpentry online on Twitter and on their blog, and I followed them for a little while, and I just sent them an email and said, you know, what would it take for you to give a workshop here? And they said, well, book a room and we'll come. And he was not kidding. It was actually the director of software carpentry at the time, Greg Wilson, who came because he was in the neighborhood. He came from Canada. So he taught a workshop, and it was really a fantastic experience. It was right in the middle of what I needed. So I was, and Karin as well, we both attended, and there's actually at least one more person in the room that attended, and we had a great experience. But this is a pyramid scheme. So software carpentry and data carpentry are pyramid schemes. You go to a workshop, and then they try to recruit you to become the next generation. But it works. It works. It's a pyramid scheme that works, and I like it very much. So we said yes, and we went to the instructor training and started giving workshops both locally and actually even in other countries. So around spring 2013, we were finished with the instructor training and became officially certified instructors. And I think that's a pretty important part, that the focus is very much on having people go through a training process before they are certified, a stamp of quality. And then we found the library, and Leah said without us it would not have been possible, but I think we can equally say that without the library it would not have been possible. And the library, the science library here, saw the potential of these workshops, and they helped us by taking a lot of the work around organizing workshops, the booking of the rooms, and the coffee and the tea, which are extremely important, out of our hands. And we started early 2015, so we're only doing this on a somewhat larger scale for a little over a year. And so a year later, last February, we had a workshop which was number 4 in this effort. 3 last year, 1 this year. We have more than 100 PhD students, postdocs, master students, and other staff attending to these workshops. So we're still teaching the standard software carpentry curriculum. The material has been developed by people that are very good at this tools, but then they go out in these workshops and test them, and they get feedback from other people that test them. So it's really, really polished material. There's a large community of people that contribute to the material, and that's why it's working out of the box. It's really fantastic lesson material. So far, we've not been able to teach Python, but we're changing that. We're getting at least one instructor that's able to teach the R module. And we're teaching people from everywhere, mostly mathematics and natural sciences, geosciences, biosciences, astrophysics, pharmacy, mathematics, informatics, museum, chemistry, and the science library. But also from medicine, they're swamped with data as well, and even one person from the humanities. And then after the workshop, you send out surveys to people, and also Tracy showed some results. And one of the last workshop survey results, even though not that many people responded, but 9 out of the 10 respondents say that I agree or strongly agree that the workshop was worth my time, and I will actually recommend it to my colleagues. So it is something that we can say back to the library and others that this is worth organizing. And how do you perceive the pace? This is kind of trying to go into a little bit of the problems of these workshops. People come in from all kinds of different skill levels. So for some people, the workshop is way too slow. For others, it's a bit too fast. Luckily for most people, it's fast enough. And it's an art as an instructor to make sure that the whole room is happy, that people that are bored don't fall off. Actually, the people that are bored because they know this stuff very well, you can try to recruit them as helpers, of course. But then there's possibilities to organize more advanced workshops with material that's more tailored towards people that know this, but want to go to the next level. And I'm going to quote, I don't think she's here, I'm going to quote from a blog from the humanities person that went to our workshop, and that wrote a blog post after she took the workshop. I've participated in my fair share of technology and programming workshops over the past years, and I have to say I was awestruck. The instructors were wonderful, the mode of teaching was working refreshingly well with quite a heterogeneous group of learners, and the overall atmosphere was friendly, helpful, encouraging, and explorative. I don't need to say more. So now we have been much faster than I thought. We've been able to grow the group of people at the university that's involved in this. And I think after this week, we can add quite a large number of helpers and potential instructors. So we're currently at 10 certified instructors and 10 workshop helpers. Those of you who are here, please stand up. I know I've seen a few faces. Helpers and co-instructors. Thank you so much. And now I'll give the word to Karin.
Well, we are planning to continue our efforts and we want to scale up. One of the first things we want to do is to increase the number of workshops. I think we're almost succeeding to get our goals with this week. We started out this year thinking 6 workshops this year. And I think with this week, I think we're at 5 or thereabouts. So I think we new goal 10, 12?
Probably.
Yeah, something along those lines. A lot more workshops. We also want to add more instructors. We would like to possibly double our instructor pools if we can. That, of course, requires interested people, and so far we haven't lacked that, at least. Another goal for us is to start something along the lines of an alumni group. So have happenings, meetups where people can come, where we can talk about the things we teach in the workshops and also similar things. So low-level learning events. I've heard some other institutions having these as kind of data therapy sessions, and I think that says something about the pain some people encounter when they try to mangle these data. We would also like to expand on our curriculum. We would like to add R and databases and also other lessons on automation and the like. We also want to have workshops where things become more advanced. We have Software Carpentry, for instance, has more advanced version control things that we would like to do. Also numerical programming in Python, which I think would be very useful for some groups at the university. And of course, we would like to add data carpentry lesson material to our to what we teach. And we're very happy that we are starting with that this week with not just 1 data carpentry workshop, but 2. So that's quite exciting for us. And in that connection, we're quite proud to be able to announce that the University of Oslo is, as of last week, I think, I think Liva, have we signed the papers yet?
We're trying to sign them electronically and get them.
Very close to being signed.
So both data carpentry and software carpentry works on a membership model where institutions sign up and help support the foundations that way. And we're very proud that University of Oslo will be joining the ranks of those who do that. On a more practical level, becoming an affiliate, the university will be supporting the two foundations. It will help us to a larger extent to fill the gap in training that we see at the university. And this will be happening because we'll have a lot easier access to instructor training within software carpentry. So that's also very important for us in going forward because we need more instructors, and becoming an affiliate will help us get those instructors faster. Last but not least, we would like to thank some of the people who've been helping us a lot along the way. Not in the least, the Science Library with Liva, who in some respects have been acting as our guardian angel. You've given us a home, a place to be, which has helped us a lot. The Faculty of Mathematics and Natural Sciences, Arnstein has been working, Arnstein Orten, has been working a lot with us to try to get software carpentry and data carpentry more integrated with the university. And we're very grateful for that. Also the University of Oslo as such. And all the instructors, helpers, participants, and everybody else who's been part of organizing this effort. So, thank you.
Well, you deserve much more than chocolate. And cynically for the University of Oslo, getting people to work for themselves and others on this level, and training this many people with the low costs, that it's really a low budget thing. So congratulations in getting this far. Now we'll hear from give them a big applause.
Thank you.
Roar Skålin is the next person speaking to us, and he is from the Research Council, Norwegian Research Council, and he will talk a bit about the research funders' policies on access to research data. So welcome, Roar.
Thank you very much. Thank you for inviting me, and thank you to the Science Library also for taking this initiative. So I will talk about research funders' policies. Now, of course, the biggest research funder here at the university is the university itself. Their policy will be covered by the next talk. So I'll talk about the policy of the Research Council of Norway, and as well of the Horizon 2020 program of the European Union. So let's jump to it. We do have a policy at the Research Council. It's a policy for open access to research data. It covers the research data that is generated through research, partially funded by us. Of course, we cannot say that everyone should follow the policy, but we could say that all the projects partially funded by us should follow this policy. The policy is simple. It's open by default with some exceptions. And those exceptions are the usual ones. It could be security and confidentiality issues, protection of personal data, legal requirements, and also we do fund innovation at the Research Council, and of course then there will be some commercial use, so that could be a reason for not having the data open. And then we have one point which not everyone includes, and then we say that the data where the cost outperforms the value of open access, well, then you don't have to do open access. So you have to do a judgment yourself. What is really the cost of preserving this data compared to the value? We have chosen to take a carrot rather than a stick approach. The reason for that is we did a survey among 7,000 Norwegian scientists, and they were generally positive towards open data, but there are some elements missing to implement it. So we would really like to strengthen the positive attitude that's there, but at the same time we realized the tools are not there yet. So we formulate this policy as guidelines and principles, which are recommendations and best practices, not absolute requirements. See, here are some examples of these guidelines. I'll not read all of them, but mention a few. So the data should be archived at established data centers, not on your own PC, but established data centers. And the examples are Norw, which is part of the national e-infrastructure covering large data sets. NSD, which now has the name Norwegian Center for Research Data, which stores data in the area of social sciences, humanities, climate, health, environment. And then you have domain-specific solutions like Elixir for the life sciences. Another one is that we say that you should make the data available as early as possible, but we allow you to have an embargo period so you can publish your results before making the data openly available. We do encourage you to use licenses on the data. That's good for you and it's good for the users. The users know what they can do with the data if you equip them with a license. Without a license, they don't know what rights they have. And you should have a plan for long-term plan for data curation. What do we do to implement this policy? Well, we have a couple of mandatory rules. One which has actually been in our contracts for many years, and we say that it's the obligation of the project owners. That's not the scientists. The project owner is the university. It's the obligation of the university to ensure that all these data are stored in a secure digital archive. Then we are working on how to handle data management plans, and in some form we will request data management plans. I'll get a bit back to that. We have, as from last year, said that all the costs relating to archiving and publishing open data may be included in applications for funding. So they are eligible costs. Then we are funding a number of infrastructures that facilitates open access to research data. Up till now, we have funded approximately 30 infrastructures. Some of them are here at the university, and Norw is one of these. They are mainly in the areas at the geosciences, life sciences, social sciences, and humanities. We want to establish an arena for dialogue and learning between the service providers and the data archives, libraries being one part of this. And then we work on the international arena to establish rewards, incentives, standards, and not least infrastructures. What is a data management plan and why should you have one? Well, a data management plan is there to help you to think what what is the value of my data, how should I preserve that value, and how should I make sure that others can exploit the value of my data. Data management plans have been part of applications for funding in the US for some time now, and it's gradually coming here in Europe as well. For now, I think the UK, in UK, it's you have to have a data management plan with your application. The problem is that not very many scientists know how to write a data management plan. And we have also experienced that not very many reviewers of applications know how to review a data management plan. Luckily, things are happening. There is a very good tool for writing data management plans, which has been developed by the Digital Curation Center in the UK. It's called DMP Online. This is the one we recommend, and this is also the one which is recommended by Horizon 2020. And it will be translated and adapted for use here in Norway, so that you will get an easy tool for writing your data management plans. Yeah, and here I mentioned the Horizon 2020. Horizon 2020 has a pilot on open research data. If you participate, if you get a grant from Horizon 2020 and you participate in this pilot, you have to write a data management plan within the first 6 months of the project. And if you do that, you will have to deposit the data in a repository of your choice, but it will have to be a repository that takes care of the data for long term. You will have to take measures to make it possible to access, mine, exploit, reproduce, and disseminate free of charge. So, for instance, using the Creative Commons license, such as we do. And you should provide information about the tools and instruments to exploit the data and validate the results, and if possible, also provide those tools and instruments. The good thing here is that Horizon 2020 will cover the costs. So costs relating to implementation of this pilot is also eligible costs and included in your grant. Now, this pilot is exactly that. It's a pilot. It's not mandatory. You can, for very many reasons, say, yes, I have a project, I will generate data, but I do not want to be part of the pilot. And you can use, well, any of these reasons, and the last one says there are other legitimate reasons not to take part in the pilot. And you can even opt out during your project. However, if you are in there, you will get help. The European Commission has also funded a number of projects to help you with taking care of your data and giving access to your data. One of these projects that they have funded is called EUDAT, the new version of it, EUDAT 2020. University of Oslo takes part in that project. Now, this is very much in the process of being established, and there are a lot of words that characterize this open data movement. There seems to be some convergence now, and there will be an article coming out soon discussing the FAIR guiding principle for scientific data management. And FAIR means findable, accessible, interoperable, and reusable. So these are quality marks of open data. So that's a concept I think we will hear more about. This is one thing going on. The other main thing which is very much discussed within the European Union now is something called the European Open Science Cloud. Now, you think that, well, most people associate with the cloud some data somewhere. You don't know exactly where, but you can access them. Well, there has been a high-level expert group trying to figure out what the European Open Science Cloud is, and the leader of that group, he says that, well, it's not European, it's global. It's not a cloud, it's all the tools that you need. It's a virtual environment for all European researchers or globally to store, manage, analysis, and reuse your data. And it's not only for science. It could be also for public use of the data and for official use, governmental use of the data. And it doesn't even have to be open, because this cloud or system should be available also to those that have, for instance, data that has to be protected because of privacy reasons. Exactly how this is going to be, we don't know yet, but we are pretty sure that this will be funded, partially by the European Union, partially by others. It will come to a PC near you. Exactly now, when it will happen, I don't know. But this is something to watch out for. So I think that's it. Thank you very much.
Thank you, Roar. There's your little chocolate box. And welcome back, because we would like to maybe a more extensive version another time. The next speaker is Alexander Jensenius. He is currently the head of the Department of Musicology. He was here 4 years ago and helped open the science library with his mobile orchestra, his iPhone orchestra. We enjoyed that, and I'm sure we will enjoy this a little.
Well, thank you. It was fun being here with the mobile orchestra, and I hope it will be fun now too. So I guess I will be speaking here with 3 different hats. First of all, since I was a member of a group that wrote this report here on the on open data, open research, open access here at the University of Oslo. Also, as you mentioned, I'm head of department, so I'll also have a few thoughts on, because I guess I got the title for this presentation, which said that I should talk about also how we motivate people to do these things, right, out in the real world, in the departments. So I guess I can talk a little bit about being a head of department, trying to force or help people to do these things. And finally, I guess if I have time, I'll also talk a little bit about this as a researcher and a user of these things as well. So I guess that will be the perspectives. But first of all, so last year we had a working group with people from all over the university looking into the question of data and how they are used and stored and shared, etc. at the university. And the full report... oh, did I miss something there? Oh, should have been something in between. Anyways, the full report is available online, only in Norwegian, if you're interested. One nice thing, though, is that this was on the front of the report, and it's kind of nice to remember that even though we are doing everything digitally these days, open data has been around for a long time, really. So it's just a good reminder. Also, since I'm coming from the Faculty of Humanities and keeping the history with us throughout all this. The question we asked when we started working in this working group was, okay, we're going to try to figure out how to do this at University of Oslo, but then we also need to figure out, okay, what's the status right now? So we did surveys throughout the entire university, at all the faculties, and trying to also get in touch with as many local groups as possible, to try to figure out, okay, what's the state of the art or status today at the university? And of course, you get lots of different answers, everything from people doing really the most fancy thing you can do on the planet today. There are several groups working in this way that have everything is as it should be, stored in big centers, data management plans, etc. But on the other hand, most people, I have to say, a bit embarrassingly, well, many researchers are storing their data on USB drives, in paper somewhere, they don't really know, etc. And of course, hopefully most people are somewhere in between. But this is, I mean, at a large university like this, the variation is huge, right? And also we have lots and lots of people doing research on their own. And we have people working in smaller groups, and we have people working in larger groups. So there are many different things happening at university. And we have to remember that we still also have a lot of material that is still not digitized. Right? So we have a lot of archives also at the university, in basements, for example, around on campus here. There are tons and tons of paper that is not scanned and available at all. So that's another side of the story. Okay, so to get to the conclusion of what we wrote in this report, and I guess I should have now the previous presenter stole a lot of my points, because we had also looked at this report from the Research Council. But there are a few differences, and I'll just go through some of the guiding principles that we kind of try to summarize in our report. And of course, one thing is that we need to think about the whole cycle of data from when you start, and that's also really one of the points of having a data management plan. Another thing we came up with, which may or may not be that obvious, is that we need to think globally. We cannot just make solutions that work here at university, because people will immediately start to talk about, okay, well, how do I communicate with my colleagues somewhere else around the world? Also important is that not all the problems can be solved here at UIO. We can solve some of the problems, and perhaps we should encourage some of the solutions, but we cannot do it all. And again, it's also about the carrot thing. We need to encourage people. We need to make solutions that actually help people. So from our group, we also... That's on. Let's see. Let me click here. Ah, there you go. We came up with a few action points. We made some guidelines that we'll present very shortly. We also suggested having a pilot project to actually try out this in practice, and also to make a policy regarding the division of labor between institutions, both nationally and internationally, and also figure out where the University of Oslo can take a lead, and also to encourage finding solutions. So the guidelines are quite similar to the ones from the Research Council about the security issue, reuse issue, again, also making data available as early as possible. Metadata, of course, is important. The licensing issue, again, and also that ideally everything should be available freely, but of course there may be some costs related to this as well. Now, for the solutions, and now I guess I'm switching a little bit away from kind of the report that we made and kind of moving more towards kind of the head of department part of me, where trying to figure out, okay, how can we make solutions that actually work for people out there? And I guess one of the big problems at the university like this is that, again, there is no solution that fits everyone. So we need to make solutions that work and can be scalable from the kind of individual researcher sitting in his or her office to the large groups that we want to cater for as well. And perhaps the most important is to try to work on, if you think about these as three different levels, you have the silent type of people up here, but they more or less have the solutions they need, right, and the knowledge they need. Then you have the group of people with the USB drives that they try to plug in different places and send in the posts in different directions. There it's more about trying to kind of educate people, right, and really try to just explain, well, and another thing we found out is that not everybody knows about what we mean with data at all. If at my faculty, the Faculty of Humanities, if you ask people about if they have any data on their computer, many people don't really know what you mean, right? I say that they have data. If you have text material, text corpus, for example, I would say that's data. But I mean, in many disciplines, that you may not talk about that as data at all, right? I mean, you just have your material in a way. So that's also important to think of. And of course, then you have the people in between that have kind of moved away from, they know that they have data and they want to create something and to share, etc. But they don't know really how yet. And I guess that's also a very important group to target and really to make solutions that work for them. A critical point here is that of building knowledge in the organization. And then I'm thinking about not building knowledge. You need to build knowledge at the top level in terms of and the technical administrative support. But again, we also need to build knowledge around among researchers and among all the students to figure out how can you actually do this? And again, as the examples of the previous presenter showed, I mean, there are lots of solutions now, but if you talk to the individual professor in her office, as I do each day, they have so many other things that they need to think about in their lives, right? I mean, they're going to do their teaching, then they just need to get their funding applications written, they need to do to write their papers, and then again, how to do the data management. If they don't have any support at all, that's a tricky part. So again, one of the things we talked about quite a lot in our group was that of also acknowledging the need for data scientists. And again, for some people and in some disciplines, this may be obvious how to handle data, but also that this is something that is being really covered and also explained throughout the university. Taking, for example, also my own department and faculty into account, the need for really knowing about how to handle data, and that is also a profession in itself. And finally, education. We also need to figure out how to really get this out to the students. And again, this may seem obvious, but it's not an easy task how to do this. But again, by developing good systems and solutions that work well, work better than Dropbox or Google Drive or whatever, then we may be able to get there. I think that was really what I wanted to say. I didn't bring any computers or mobile phones or anything to play with this time. That will be next time, but hopefully that was a very few points for me to kind of just talking about how things are at UL at the moment. Thank you.
Some chocolate for you too, Alexander.
Thank you.
And then finally on to Leah A, who will also be teaching the Data Geo workshop this week. So we're pleased to have you here all from Boulder, Colorado.
Yes.
Where you work with the NEON open data and supporting data skills. So, welcome.
Thank you. Thanks. So excited to be here today, and I just wanted to start with a short story of being a graduate student and working in ecology and ending up working with LiDAR remote sensing data. And I was so excited to get started, and then I got my first data set that was over 30 gigs, and I knew Excel, and I knew ArcGIS, and I tried to bring that data into ArcGIS and start to manually process it, and realized that it was going to take me years with that approach. And so quickly I learned I needed an alternate route, and then a friend introduced me to MATLAB, and I started to learn how to program and automated skills, and that's kind of the path. And then I went to a new job at NEON, where I am now, and I had to switch to R, and then I have to use Python, because everyone uses different languages and different tools, so you kind of have to adapt as you're working with different people. And so I felt the pain that Tracy was talking about associated with working with data, but I've also felt the pleasure and the happiness associated with being able to process your data and getting your results and being able to actually do research. So this whole process is really important, and this need for data skills is real, and we're all feeling it, and we're all on the same page. And so I think I'm speaking to, I think we all kind of are in that same space. And so I wanted to just quickly tell you a little bit about NEON, where I work, and then I'll tell you about how we're kind of a part of this whole data training initiative. So NEON is the National Ecological Observatory Network. Our headquarters is in Boulder, Colorado, and we are collecting and providing data for 30 years to support the study of ecological change, both the causes of that change and the drivers of that change. So we're talking petabytes of data coming out of our observatory, and it's all free and it's all open. And a little bit about our design, just if you haven't heard of us before. We have sites across the United States, so we have lots of sites, and each one of them is very different to represent ecological heterogeneity across the whole United States, so that you can begin to look at change over time across the entire country. And then at each site, we have a suite of measurement systems. So we have things like flux towers at all of our sites, collecting temperature and precipitation and wind speed, and we have instruments in our streams and lakes collecting aquatic information. We have field techs out sampling trees and getting information about small mammals and insects. So we have a whole suite of data, including also a remote sensing platform, our airborne observation platform, that is going to be flying these sites every year. And all of these pieces together allow scientists, so you, anyone that's interested in doing research in the continental United States, to really characterize ecosystem structure and function over time, so that 30-year time period. And then to scale from the site level up to a regional level using the remote sensing data. And then at the entire country scale, we have global data sets like Landsat and MODIS, satellite-based data that are available to support that scaling process. And then all of our data are online. We're just building the observatory now, so they're starting to come online. You can go to neonscience.org and check out our data, download the data, request the remote sensing data. Everything's free, everything's open. All the documentation associated with how we set up our sensors, how we process our data, everything is open. It's a community resource. So with that, we've got all of these data, but the question is, how do we use all of these data? Because actually it's quite complicated. It's in lots of different formats and lots of different data types. And so this need for data-intensive training is very relevant to NEON because we need to support the community in using our data. And by the way, if you're not using NEON data, you're using some other data, a lot of the skills are the same. Understanding file formats, understanding dealing with spatial data in different projections and coordinate reference systems. So those skills, we want to contribute to this community who is supporting the science, supporting actually doing the science. And of course, getting back to where I started as a graduate student, it's not going to happen in Excel. Excel is great for some things, but not for big data analysis. We're not going to do analysis there. So these automated skills, R, Python, whatever the tool is, we need to develop resources to help each other work with these data. And so at NEON, we have a whole education component. In fact, it's a major component of this project. And some of our educational components related to data skills range from workshops. That's why I'm here this week. I'm so excited to be here to help teach some of these data skills and the spatiotemporal focused lessons. We do science videos to teach key science concepts. We have teaching data subsets. So one of the big challenges if you're trying to teach this stuff is where do you start? And if you go and download a huge data set, to actually be able to teach how to work with that data set, you have to do a bunch of work as a teacher and as an instructor to put the data set together in a way that it's small enough that a student can learn something, so they don't get stuck downloading these huge data sets. So we put together teaching subsets as well to support that learning component. So neondataskills.org, for anyone that's actually coming to the workshop this week, that's where all of our online tutorials are right now. And we have collaborated with Data Carpentry on developing a lot of those materials. So this is the site, and you can go here, and we have tutorials on lots of different topics associated with spatiotemporal data. So things like, how do you work with LiDAR data? Or how do you work with HDF5, hierarchical data format? How do you bring that into a tool like R? What is the structure of the file format? If you understand the structure, actually you can carry that information to a lot of different tools if you need to work with it. So we try to provide some of those foundational skills to work with those data. And everything here is free and open. It's all on GitHub. You could go and fork the lessons and adapt them to a teaching environment that you were working in. So this week, we're teaching our spatiotemporal data lessons that we developed collaboratively with Data Carpentry. And so the way we started this was we picked a science theme. Now, this one happens to be phenology. Just because you don't necessarily work in that area doesn't mean that the skills aren't relevant to you, but we picked an actual science theme and said, what data would you need to get to something like this where you're trying to plot a trend of greenness over time for a large area? And so here's that kind of initial concept. And then thinking about all of the skills needed. So you're going to need to understand something about spatial raster data, no matter what format it's in. You're going to need to know something about metadata, because you're probably going to download the data from somewhere. You're going to need to know something about what kinds of packages or libraries, depending on what tool you're working in. And then there's going to be a whole process associated with importing the data, cleaning it up, and visualizing it. So that's kind of our workflow. And then the workshop addresses those things and then gets to endpoints like, here's how you visualize a whole set of Landsat rasters in R. Or here's how you deal with coordinate reference systems, because they'll really mess you up. If you have data in different projections and you try to work with them together, it's going to be a problem. So understanding how this works, you can kind of address that problem before you encounter it. And then again, the teaching subsets. So we've put together some data sets that are clipped to smaller spatial extents, smaller data sets that will be easier to use in teaching, because if you're trying to process huge data sets in a workshop, it's just going to be very challenging. So these are available. They're all on Figshare. So when we do all this work and put these data sets together, anyone could go to Figshare if they wanted and use them for teaching. Again, following the data and software carpentry model, this is all collaborative. Everything's on GitHub. Anyone can use any of our materials. And you can also contribute to it. So you can comment on, this didn't quite work for me, or give us suggestions as to other types of lessons that we could build that might be helpful. And then a few other pieces of our program. We do workshops, like this one today. We go to a lot of scientific meetings and have workshops there where there's a big audience that is already taking resources to attend the workshop. We'll organize, or to attend the conference, and then we'll organize a workshop around that. And we've just gotten great feedback on our workshops, which is really exciting. So lots of good feedback from the community. And they typically fill up, and we typically have waiting lists. So that just speaks to the demand for data skills. We have science videos if anyone's interested in checking that out. When you go to Neon Data Skills, you can go to the science video section, and we have things on what is LiDAR, and just kind of 5-minute quick animated videos that teach data concepts. And then we have other programs like an internship program, and we're doing a remote sensing and science summer institute this summer. So with that, here's the URL, and you can tweet. My Twitter's not on here, but there's my email, and my Twitter is Leah A. Wasser. And thank you very much for having me.
The official chocolate.
Oh, thank you.
And we thought to conclude this session with some questions from the audience, maybe. And I've asked Arnstein Horten, who was previously presented as the other guardian angel of software carpentry. So please, Arnstein, guide us through the... Yeah.
Okay, thank you so much for everyone who has presented here today. I'm wondering, Leah and Hugh and also Tracy, thank you. Could you please come up on stage, and we'll get you mics. And if anyone have questions for any of the people that presented here, please raise your hand, and I'll come around with a mic to you. So just a couple of minutes set up. Yeah. Okay. Please step up on stage.
Og så var det en mikrofon som datt fra hverandre, sånn at hvem av de er det som kommer til å snakke mest, og de andre deler en hånd opp. We'll just hold it. We had one more.
Officially the 3 degrees.
Technical difficulties, always funny. Okay, so as I said, if you have questions, please raise your hand, and we'll come around with the mic. Now, to start things off, you've all heard the other people having their presentations. Do you have any comments for the other people? I mean, I heard several things I could grab onto, but I'm wondering what you think.
Well, the first thing that was really nice was it was again recognizing the sort of commonality there. So Alexander's talk, although he was sort of focusing on a domain for one particular university campus, I completely found that he was more or less repeating the same things were there. So there's a really, the solutions are really universal to the ways, the problems are universal too. So, and that I think is a good thing, that if one place figures things out, actually that very much the same ideas could be applied elsewhere.
Yeah, I mean, we have all interacted with each other either in person, although this is the first time I've met Hugh, or via email or conference calls. So we are generally aware of each other's efforts, but I think that is what was great to hear again here, is this synergy where we do really, have come and we're coming from the same place and we're working together, whether it be in different domains or different geographical regions. I think, us working together is really powerful, and it was great to hear even more about what everybody was doing. I don't have anything negative to say. They're all great.
Yeah, I'd just like to add, well, this was just fantastic, but the piece that harkened the most was that slide with, in 5 or 10 years, this is going to become comfortable and normal to scientists and to faculty. And I think that, the university level support of these skills and then integrating it eventually into coursework, just like writing is integrated, writing proposals, some of those, it's a core skill, just moving to that end goal and working towards that now, I think that was the piece that really resonated with me.
Yeah, I think several people are interested in that. I mean, how, in an ideal world, how should we get these open data skills into our education system? I mean, software carpentry, data carpentry, I think that is a great solution for our university at present. Do you see that as the end game, or should we do things differently, or do you have any thoughts on that? Any of you?
Yeah, I think obviously I value software and data carpentry, but we exist because there's a training gap, right? We're in some sense a stopgap measure because these aren't available in curricula. So, 5 years out, I'd love to see this integrated into curriculum, not in a sense of, another one course that you take, go take your data course, but really integrated into each domain. So, I love the talk on archaeology, is fantastic. And, to have an archaeology course, it's called an archaeology course that includes working with data and these skills just baked in much the way that some universities are adding writing. I think just data literacy is foundational. So kind of an organic piece of the curriculum. And it might take a while to get there, but I would love to see things headed in that direction. And that is part of our goal long term, is we're starting with workshops, but we envision working to help get things into course curriculum. And we have now some materials for a semester-long data carpentry for biology. So.
Okay. I completely agree, and I think that one of the pieces that data and software carpentry are really excelling at is train the trainer component, and there's a reason why there's however 100 or so people on the waiting list. Teaching these skills is not the same as teaching writing or teaching a normal biology class. And so I think there's certain skills associated with teaching it well and getting to that integration. And so I think some of what we could potentially think about now as well is just getting those teaching skills specifically for software or for programming into the hands of faculty and kind of building in that area a little bit more.
So if maybe I'll be the one who'll introduce a slightly negative note, but I'll slightly negative note against what we're doing so far. So a few weeks ago we had a workshop in Amsterdam, and we got a whole bunch of people to give us sort of feedback on what we were proposing for our schools. And when they made, I think, one thing which was a very, very salient point, and it's something that I need to sit down and look at in terms of the courses that we're developing in any case, is there was a slide, they said, we get the fact that this is really good and it's important, but it has a slight as the Americans might say, an eat your greens sort of feel about it. In other words, in the same way that, you know, people teach calculus, first year calculus, Calculus 101, and it's like, we teach you calculus and that's good for you, you know, and trust us, eventually it'll be good. So I think, at least for you know, next iteration for our schools is to think, you know, how do we really show this is you do this and this will make you more efficient and make you better. We're pulling in all the people who are really enthusiastic and are the first generation people who are going and do that. But the next generation, the people who are a little bit like, yeah, but is this really going to help me with my next paper? I think we need to show that and really sort of prove the case that there. And it's just a matter of pulling out the use cases and just saying, look, this happened, you know?
Yeah, so I really agree. I think a real challenge in sort of open science, open data, and I think a few of these speakers alluded to it with this idea of, why should I do this? You know, oh, it's for the common good, or will someone scoop me? And so actually in workshops, we are committed to open science, open research, open data. But the way that we present it and the topic of reproducibility is not so much this, you know, altruistic aspect, but reproducibility for yourself. So in 6 months from now, when you don't remember what you did, you know, if you've documented your code, if you've said where your data is, and I see people nodding, so that's a good sign. You see what they say, you know, the you of 6 months ago is terrible at answering email, right? So, you know, or the reviewer comes back, reviewer number 3 wants you to redo an analysis. What's that going to look like for you right now? Is that going to be you freaking out and not remembering where your data is? So here's better ways of doing this for you that then translates into a pathway to open science and open data. Because as a concept, it's kind of intimidating. There's lots of things around it that are how to do it, which is one thing. The other is just culturally or socially, you know, what does my field say of that? And those trends are changing. I'm really excited to see over the last few years those conversations even shifting. So I think we want to come at it from sort of all the angles. You know, this is good for you, and then this other sort of the advocacy. So I don't know if you have.
Yeah, I think we can all agree. We have a question. Wait for help.
Do you want this one? We can hear you. We'll repeat the question.
Try this one.
Thank you very much for your presentation. There, am I not going very loud? Thank you very much for your presentations. I'm very excited about the workshop. And I have 2 questions. Let's go first for the practical one. I didn't have any information about the second week of visualization of scientific data. Is it going to be in Norway, in Oslo next week? Or I got a little bit confused with that. And my other question is, I am very interested in brain imaging and the kind of how can we use these data sets. I wonder if you have something about that kind of abilities. Thank you.
Okay. Well, okay, so maybe I can answer the first part, which was, yeah, it's a bit of a whiz through everything. So as you said, I'm speaking about this particular set of schools that are running in Trieste in August, and they're the ones which are 2 weeks of, so that's quite a long one. Well, here I believe it's a week. So yeah.
I'll speak to the neuroimaging. Yeah, so conveniently. So neuroimaging data is one of the domains that we're thinking about. We do have a start on a neuroimaging lesson, specifically working with neuroimaging data. Actually, if you go to the Data Carpentry repository in GitHub and you search for neuroimaging, you'll see a draft of some materials. Ariel Rokum at University of Washington has been leading those efforts. So that's on our roadmap. And to get started, you know, that might be even just a place to look if it's something you're interested in. And, you know, we'd love to have your comments or involvement or anything on that. So thanks. I'm always glad when more people are interested in things that we're thinking about. It's a good sign.
Okay, we have a question down here. Just a moment.
I'm curious how to balance the user privacy and the data utility. Because you are trying to persuade other researchers to open their data, right? And I guess there is a question about the balance between the data utility and the user's privacy.
Yeah, so I don't think any of us are really qualified to speak on the user privacy issue, but in fact there are very specific rules around any human subjects data and specific ways that you have to handle it. And so open data in human subjects research is a whole other area of focus. So we aren't advocating for release of data that includes personal information. So I think Norway has the same kind of laws around human subjects data. US laws are very strict about that data, whether it's social science survey data, whether it's genomic data, they're very strict laws. So if any of that kind of data is open, it needs to conform to very clear expectations that anonymizes that data.
Okay. Yeah. Thank you so much. So I can try to partially answer your question. As Tracy told us, there are very strict rules also in Norway, and in general, privacy data cannot be open, and you have to apply to get access to them. You have to apply to official committees in Norway that will look into your project and see if you qualify to get this data. If you do, we now have technical solutions to give you access to the data, including what here at the University of Oslo, they have developed something called tjenester for sensitive data, services for sensitive data, or would that, I guess, be in Norwegian? So then, if you are allowed to get access, we have technical means to give you access. Then the Norwegian Research Council have funded a project that will give you access to such data on an anonymized basis. So you won't get the real data, but you will get statistical values. And that is handled by the Statistics Norway, this project. So we are working on solutions for it, but we have to follow the legal rules.
Yeah, and to follow up there and perhaps complicate it even further. So in Norway also we have this, you didn't mention NSD, which is the National Science, it used to be the National Social Data Science Service, but now it's they changed the name. And there you can go and look at the data that you can request. In our working group, we did discuss this privacy issue quite a bit, and there are several also projects on campus now looking into this. Also from my own field of music, we also have the property right issue, the copyright performance, when we have performers and composers involved in this, which further complicates sharing data. So I'm not really sure if this is a question to the others or not, but it's just it is a very complex matter, and also we have many different types of laws in the different countries as well. So this ideal of making everything international is also problematic from, for example, from a Norwegian perspective, because we have to kind of also protect our Norwegian laws.
Yeah, even our survey data, when we conduct our surveys, pre-workshop surveys, we try to get information about the people who will be attending to help the instructors know who their audience will be. In the US, we collect demographic information because it's important for reporting on grants, but in Europe, we don't because it's not allowed. So yeah, there's even different considerations around data collection. Yeah.
Any other questions? In that case, thank you so much, everyone who have been on stage. Oh, do we have sorry.
I'll take my chances. My background is I train librarians, and I'm wondering about the role of librarians in the open data management and what your views are on that.
I feel like we should have Liv answer this, but I love librarians. I love libraries. So I think libraries play a crucial role in this, and I think universities are starting to see this. I'm really seeing libraries across the world really take an initiative in terms of being involved in training and guidelines around data practices, and really that whole life cycle. Because I think librarians think about data in a way that most of us don't, because they're used to sort of these archival and provenance issues. And so I think the thinking is one thing, but the other thing is that libraries are a place at a university that has a service role that most other places on campus don't. And so I think they're well positioned to interact with the whole university community on providing these perspective and skills. What's happening right now, I think, is that people aren't looking to the libraries for that. So I know in a lot of cases there's a lot of things going on at a library that people in science or aren't aware of. So I think we still need to build those connections. And from a data carpentry perspective, I would love it if we could go to every library and interact with them to help scale out programs on their campuses. So I'm so excited to see what you're doing here. And it'll vary by library, too. We also are developing a library carpentry, which is to teach librarians some of these skills, because a lot of people now are coming out of schools to libraries that come with these skills, but there's people in the library system that want to learn them. Now, databases are digitized, but don't have these skills yet. So, I don't know, June.
Yeah, I mean, just to add to that, it's hugely important, especially as we get to a point where every country has saying, every research council says, okay, you have to have a data management plan. The librarians are, in some respect, the obvious people that researchers can just say, can you fix this? And again, if having librarians, even at the very start of that process, so that researchers that know that there's somebody there to talk to say, how do I annotate all this stuff? How do I, what are the right standards for me to use here? Show me. Those I think are absolutely crucial, because we're in a dangerous situation now where we're churning out huge amounts of data, and because it's not being annotated properly, it's just so many zeros and ones. Yeah. There you go. Sorry, I'm being
No. Only one small piece to add is that CU, University of Colorado and Boulder, they have a data scientist in their library staff now, and they're actually pushing and organizing a lot of these workshops that are happening on that campus. And so I could see that model, and I'm sure that's happening at other universities as well, being an ideal model, because then you have a centralized location for organizing training, for providing information about things like data management plans and documenting data. And so that model seems to be one that could be very promising as we look forward.
Yeah, I don't know exactly what you should teach your student, Niels, but what we are looking for is a good division of labor between the ICT department and the administration, the student administration office, to, what do you call it, the academic administration. You know who I mean. Well, we should seek that division of labor to have this spread out in a good way. And I think, as for now, we have hosted, done the coffee part. And if I had more money, I would love to hire some data librarians. So we're really looking for inspiration for the next step. So I'd like to talk to you more about how they do it at Colorado, for instance.
And remember the researchers as well, Leah.
You have a supporter.
Okay, thank you so much for everyone who has been on stage and for everyone who came. I know I will see many of you during the rest of the week, and I'm really looking forward to that. Thank you, everyone.